innovative tricks for project requirements will change your life. Everyone's in the right spot? Are you ready to have your life changed? All right. Yeah. So, in case you don't know who I am, my name is Becky Linton. I'm a senior systems engineer for Konrad Technologies. I'm also a LabVIEW champion and a certified LabVIEW architect. My co-speakers over here, we have Chris Beuschel, one of my coworkers. He's a certified LabVIEW test stand architect, and he's lapsed on his LabVIEW certification, so get on him for that. And then we have Q here, who's also a LabVIEW champion and architect as well. And so we're all part of what we're calling the CPAD track. And so CPAD, if you haven't heard of it before, is Software Engineering, Processes, Architectures, and Design. This track was started 4 years ago by the LabVIEW champions, because how many of you have been to NI Week like a long time ago? How many NI Weeks? Quite a few? Like 5, 6? Does anyone remember the days when all the presentations were just marketing? When it was like, all right, you'd look at it and you're like, oh, new features, great. Oh, new products, great. But you didn't really get any great technical content. And so the champions set out to change that, because even though you might not be a certified LabVIEW architect, we feel that you should still be privy to the information that we feel is important to you guys, right? Stuff you should learn so you can become an architect at some point. And so the idea was we had one room and we called it the Advanced Users track. From there we set out, and it's grown significantly such that we have, I think it's 60-some sessions this year across all the rooms. So if you go back to the main floor, I don't think we have any up here right now. There's a single sheet of paper when you check in, and it's got all of the CPAD sessions. Now this year we're doing something a little bit different in this room. We're actually doing a mini track. And so we're really looking for feedback. We didn't pick out our project till a little bit later, but I want to know what you guys think of the idea. The whole idea is, in one room you could sit here all week and follow a project from start to finish. Hence why we're starting with requirements. So the idea is we get requirements, we figure out design. How do we choose a framework for our customer and our DUT? And then how do we actually implement it? How do we go about unit testing it? How do we deploy? Things like that. And so we'll see how it works out this year. We didn't give the information to the speakers and ask them to try to incorporate at least 10 minutes of their presentation into it. So again, let us know what you think of the idea in general and what you think of our implementation this year and how we can make it better next year. So this year, here's our DUT, if I can figure out the clicker. Can you hit it, Q? It's not liking me. I went too far. All right. So this is actually used by National Instruments for some internal training. They have a fake customer called Best Beam, and they have a DUT which has a linear array of MEMS digital microphones. The DUT supports 6 equally spaced microphone modules. And just so you guys know, we actually have the DUT. And I made this board up, and it's a custom PCB, and it connects to a MyRio. So they use this for internal training, like here's some requirements, here's a test, here's what I want to do. And we actually, you can see my voice speaking here. The microphones are picking it up. So I know for a fact the people covering Unit Framework as part of this track, Unit tested some of these software that NI has as their solution for the problem. So it's kind of interesting. And you're welcome throughout the week to come look at this and see what's going on. So let's take a look. This is the documentation that NI has as part of it. So we've got a CSV file example, a JPEG of it, some test limits, the format specification, and oh, requirements. I don't need to do anything. The customer gave me requirements, right? I mean, the customer doesn't want to pay for me to write requirements. They gave them to me. So let's actually take a look at the requirements. Best Beam, system and test system specifications. It's got some good sections there. Introductions, provides the information needed to understand the DUT. Here's some information about the DUT. Okay, I don't really see any requirements yet, just some information that's useful. There's the DUT. Oh, here's some more how I can find it. Here's how the data clock works. Still not really any requirements, just good information. Oh, here we go. There's a temperature transducer. There's a data sheet. Oh, it's controlled externally using SPI. That's good. Here's some hardware maps. Oh, here's what they want. Okay, the measurement setup should look something like this. There's the whole requirements right there. Generate an acoustic step sine signal, full range, couple things there. Okay, that looks like valid requirements, don't they? Does anyone see any problems? Are these really requirements? How would I trace these requirements? There's no numbering scheme. There's no way to track them. So even though this is a requirements document, it's not really the best way. And so why do we even need requirements? I think we're turning over to Chris. Is this you?
Yes.
You took out my slide. I had a big slide that said specifications are not requirements.
Okay.
Yep.
Tag team.
Tag team.
Yeah.
Okay, so before I took away Becky's slide, I wanted to talk about why requirements themselves are important. I think there's a decent chance that everybody in this room has interacted with requirements, regardless of whether or not you've written them yourself, if you've taken them from a customer, or just been downstream of having to implement these. The customer that we're talking about here doesn't always have to be somebody outside your organization. It could be your boss, it could be the guy next to you. But at the end of the day, what these mean is somebody's given you something to do, and you have to set a bunch of rules for you or your team so you can make sense of the project and work effectively to do that. Requirements give us an opportunity to baseline our project, to make these set of rules, and to get familiar with what the project is trying to accomplish. In doing so, you understand what your deliverables need to be as part of that project, and it gives you an opportunity to work with that customer to set up what your boundaries are, what your scope of delivery is, and then prevent that scope from changing. So we use these as a tool to make sure we know what we're doing, and that if that has to change, that we can kind of control what that change is. And there's a quote that we actually throw around related to requirements. It's not enough to do your best. You must know what to do and then do your best. So doing your best, going 110% on something that's not well defined, isn't going to be a very useful effort. You're going to waste your time doing things that you don't need to do or are too expensive. And requirements are a useful tool to make sure you don't end up in that situation. This is Becky's slide that I stole. So the specifications that we just saw aren't the same as requirements. There were some things in there that sort of looked like requirements, but ended up being a superset of things the customer wanted about the product, vague notions about how the product should work or how our test system should work. They didn't give us a real clear plan or set of rules on how to implement that. So our specification ends up including extra things like design constraints, which can be, I'd like to use a certain type of instrument, or I need to interface with this specific chip. That's not necessarily the role of requirements. We want to capture function and not design. So by looking at specifications, we can get an idea of what requirements need to be, but we also need to take the time, the opportunity to go through and decide functionally what are we trying to accomplish here in the scope of our own system, and leave out all the rest so that the work that we do is focused just on what we're responsible for and not the bigger system scope. Requirements should answer what is it doing and not how is it doing. That's that separation between design and function. So we know what the DUT is capable of and how we need to test it, but not necessarily saying we're going to go use this instrument or this process necessarily in the requirements. An important part of this opportunity to go through and get familiar with requirements at the beginning of the project is to also think about how are you going to prove that you've met these goals when you get to the end of the project. That's the verification stage. And so what we see here is a standard V model. Right up at front, we've got the initial planning stage. We're looking at requirements. We're building this list of rules, of goals that our project, our solution needs to meet. And at some point, we probably need to prove that we've actually done that. That's the role of verification. And by working through the requirements early and also thinking at the same time, how do we verify these, we have already set ourselves up for success down the road to say, we planned to do it this way, the system has to work this way, and this is how we're going to prove that we accomplished that goal. So the early effort saves us effort down the road, and we'll actually talk about verification in a little more detail after this. So you've got the specification. You've got a pile of documents from your customer, an example report, and some pretty pictures, whatever they want. But how do we take that and turn it into requirements that are useful, that we can track, and that we can prove we've met? This list here is taken from IEEE 29148, 2018 run. Has anybody seen this list of parameters before? Excellent. So these are a list of 8 different parameters that feed into what a requirement should be. So you can see there's correct, unambiguous, complete, consistent, ranked, verifiable, modifiable, and traceable. So at the outset, that can kind of seem like a lot to go into just one statement. Based on the scope of your project, the regulation of the industry you're working in, you don't necessarily have to focus on nailing all of these, but these are great guidelines to know whether or not you've started off in the direction of quality. Because when you write requirements, these are the rules that you have to follow when you're working. These are what you have to verify at the end of the project. You want these to be well written, to be complete, consistent, unambiguous. And the IEEE spec here is actually based on the concept of requirements engineering. And I think probably most people, even interacting with requirements on a regular basis, don't consider that a discipline of engineering by itself. But if you ever work on a big enough project, you know when your requirements document is 40, 60, 80 pages long, because the system is huge, there is an art form and absolutely a discipline that goes into deciding how do I build these requirements so the system can be successful. And this is traditionally a systems engineering type aspect. Most people, most engineers that run into projects aren't system trained. So you don't have the background in this specification, but requirements are a very easy, approachable systems discipline to give you a tool to make your project less painful in the long run. When we're writing requirements, terminology is incredibly important. The way that we write these has a direct correlation to how we're communicating to our customer, what we're trying to accomplish, and then later how we're going to be able to verify that. If you write an ambiguous requirement, you can end up in a situation where you've provided a requirement that can't be proven. Or worse, you write a requirement with terminology that you understand, but your customer doesn't. So when your customer signs off on your requirements document, you're agreeing on two different things. So what you see here are 4 standard verbs that are commonly associated with requirements. And they have different levels of meaning associated with each word. So we have shall at the top. This is a mandate. This is a requirement that must happen. The system shall do this or have this behavior. Moving down to should, this is more of a suggestion. It is not a mandate. You don't have to do it, but it's a recommendation based on the context of the requirements around it or the larger system scope. The system should. Will is more leaning in the direction of larger context or purpose. We don't need the system to do it. It's not even necessarily a process that we're recommending, but it provides a reason for the system to act a certain way. And then finally, may is where we get to just pure suggestion. The system may operate on such and such. The example that actually makes these stick well for me is you're in a receiving warehouse. So received shipments shall be inspected before entering the warehouse. That has to happen. You have to go through every shipment, maybe make sure there's no damage before it can come in the building and be part of inventory. The incoming shipment should be inspected before entering the building. Okay, it's a good practice, but not necessarily required. You may get some fall through as a result because it's not a mandate. The incoming shipments will be, okay, so we're going to do it. We're not telling you really how or who's responsible, and that makes it what is an unverifiable requirement. It gives you a suggestion. There's no way for you to prove that that's happening. It gives you an idea that it should happen. And of course, the incoming shipment may be inspected just kind of says that someone should do it, and then leaves that kind of open-ended for the rest of the document to flesh out. So I'd like to go through a couple examples and see if we can decide based on the terminology and specifically the terminology, are these requirements well written? Are they communicating what they should, or are there gaps that we want to work out? So this first one is the test software shall not crash within 1 year of use. Is this a good requirement or a bad requirement? Hopeful. All right, yeah, absolutely. We would consider this a bad requirement. It's a good intention. We don't want software that crashes, and we want it to be stable for a long period of time. But if you have a requirement that says the test software shall not crash, that means you have to run it for that time period in order to know that it hasn't crashed. And if you ever make a change, or that interval changes, you now have a test plan that lasts at least a year. So this requirement, while good intentioned, is not easily verified. You could, but it comes at tremendous cost.
And what does crash mean?
And that's a great point. What does crash mean? So it's ambiguous in the terminology. What actually qualifies? Does the software stop? Do we lose data? There's just not enough information to treat this as a proper requirement. The next one.
Oh, it went up already.
Oop. All right, well, we skipped the transition. The system shall read the UUT serial number from a barcode. This is better. This is more contained in scope. We're dictating that the software will process a serial number from a barcode. We don't get concerned about what barcode scanner is being used. We don't care about necessarily the format of the barcode or where the barcode's coming from at all. This just gives you an opportunity to say, yes, I have extracted a serial number from a barcode, and you can work from there to provide the larger solution. Yes?
Previous requirement that you had, what exactly makes it bad? Is it bad because it's hard to do, or is it bad because it's poorly worked?
It's actually both. So it's difficult to prove that anything works for a year consistently, because in order to do that, you have to see that it works for a year. Most of the time, you can't really do accelerated life cycle testing and say, it definitely worked for a year. I mean, there are opportunities to do parallel testing where you could reduce a time frame like that. But at the end, you are introducing another variable that may not actually match the use case of the product. So you've introduced a deviation between what the intention of your requirement is and actually how you're trying to verify it. And then the point that Becky made about the ambiguity of crash, that can mean different things for different audiences. Your customer, who maybe is not familiar with programming, would think crashing is maybe it stops responding for 5 or 10 seconds, whereas programmers, we would consider a crash outright, the process dies, we lose all our data. So somewhere in between, there may be something that happens that we can't actually assess clearly if that was a crash or not. Does that answer your question? Another aspect, oh yeah, absolutely.
Repeat the question.
Isn't barcode a little bit ambiguous because nowadays there's too many barcodes,
There absolutely is.
That might be an implementation detail.
That's because that's usually driven by a product. You could put that into the, sorry?
Repeat the question.
Oh, yeah, of course. So the question was, is barcode an ambiguous term to use in this requirement? And depending on the context, that's a valid case to make because there are a lot of different varieties of barcodes that could be used. By using the term barcode, you actually don't get stuck in what type of barcode. Sometimes you do want to avoid adding certain details because if they change, then you have to revise your requirements and then change your verification plan. So this is a pretty safe requirement in that regard. You could then have a separate requirement that says the software shall recognize barcodes of the following formats. And then that way you have your baseline requirement that meets the real need of the software and a secondary requirement that dictates the more specifics of how you're interacting with your product or your factory system or what have you. All right? Second aspect I'd like to pick off of that list is the completeness of requirements. A good requirement should not leave ambiguity on the table. You should have a full scope of what you're trying to say. You need to have your figures, you need to have your labels or software responses so that in the context of that one requirement, you're not depending on extra information in order to know what that requirement is actually trying to prove. TBD is the enemy of a complete requirement. However, if they can't be avoided, then you have a responsibility, mostly to yourself down the road, to know why you don't have that information. Does the customer not have a specification yet? Is it something that needs to be determined empirically? And then understand, how do we get around this? When will we know this information? And then who actually is owning that process? Is it the customer? Is it you? Do we have to do some R&D work or prototype work in order to be able to clearly define that TBD? There are cases, though, and this kind of goes back to the barcode example, where maybe the format isn't specified, it's not a critical detail, or maybe it's something we expect to change several times. There is another term that we incorporate into requirements sometimes, UCF, user configurable. And that does give you a little bit of flexibility in certain instances where you're not really giving away the whole show by allowing them the opportunity to change what that requirement dictates in specificity, but you also don't have to go back and revise your requirements every time that the customer changes their mind what style barcode they want to use. A couple examples of complete requirements. So If you have a look at these reporting-related requirements, the system shall create a test record in a database for each UUT tested. The system shall record the test socket to the test record. The system shall record the test date and time to the test record. The system shall record the operator name to the test record. And the system shall record the overall test result to the test record. How do we feel about this as a complete requirement? This is a good, complete requirement. We don't have any external dependencies. There's no ambiguity. We have individual pieces of information that belong in a report and individual requirements that tie each piece of information to the system. So we know each of these 5 things need to be in a report, and they're independent, they stand alone, and they're easy to verify. You can have 5 different steps in your verification plan that says, yes, I have a test record in a database. Yes, I have the test socket, the date, time, the operator, and the overall test result. So by having these complete, isolated results, you make it very easy for yourself down the road to prove that this all happened. Next example, the system shall display everything the operator needs to know on the user interface. Yes, you're absolutely right. This is a terrible requirement because it's very ambiguous. This goes back to terminology where what is everything that the operator needs to know? And what does on the user interface mean? We don't have any guidance on what we need to put there. We don't have any guidance on how it should be displayed. Does it need to be a chart or a graph? Does it need to be an image? Does it need to be a digital readout? So something like this is where you'd want to see something more like the prior example, where you have, even if it takes 20 or 30 requirements, one for each bit of information that you need the operator to see. So you've made it very clear what that set of information is. And then you can, in those requirements as well, dictate this is a digital readout, this is a string readout. And again, that gives you an opportunity to make it very easy on yourself in verification to show that that's actually happening.
So I have a question. I'm actually managing a project right now, and I'm noticing if you try to put all the details like you described, usually the people that need to work there, they like lays out, they cannot look at it anymore, and
Sure.
they don't know what you're talking about. So I feel that you need 2 levels of requirements. One of them should be like this, which tells them what you're actually going to do. And then for the programmer, you need the different details. Because if you're giving to marketing people the detailed one, they're just not going to read it.
Right. So I think we're not really looking at 2 different requirement documents there. You're maybe looking at a requirements document that has your granular detail. These are your rules. This is the law that you have to follow. And then maybe you have a design document that makes it a little more digestible what the operator interface is trying to accomplish. There is also organization of requirements that we'll touch on in a little bit that can help separate out the granularity of your requirements so that you're not bombarded with 2,000 requirements when you just care about one submodule, for example.
Because if you're going to replace this with 30 requirements, nobody will read it.
That is absolutely true. There comes a point where you're looking at more like a discipline problem than an issue with your documentation. But there are strategies you can take to make it a little more easy, a little more focused, so that you don't run into that problem. Sure. The verification requirements is something that we touched on just a little bit. We're looking through this V model, and this is just as a reminder to reinforce, as you're writing these, okay, we have these 8 parameters that we care about to define a good requirement, but we also really want to be thinking forward, okay, it meets all the checkboxes, but can I actually verify this? Can I, as an engineer down the road, picture a way that we're going to be able to prove that this worked, and will it be easy and cost effective? Oh, go ahead. So these are 2 tie-ins we have from the CPAD project. These are taken right out of the spec that we saw earlier with Becky. This is a requirement for the generation side. The generated level between 70 and 104 dB SPL at 10 centimeters at all frequencies between 100 hertz and 10 kilohertz. Is this good or bad? Do we like this or hate it? You don't like it? Why not? That's exactly right. So it is ambiguous, and there's actually 2 parts. It's dictating a distance between our instrumentation and the DUT without telling us what precision we need to accomplish that to have accurate measurements according to the customer's intention. And the range of frequencies between 100 hertz and 10 kilohertz is potentially infinite because we don't have a step size. And if we look in the customer spec, we'll actually see it's not in linear increments, but they're actually sparse. So this is a place where maybe you have a requirement that dictates these are the frequencies that we'll generate on, and give yourself that opportunity to reduce your design complexity and pick an instrument that meets the actual requirements of the intention. Second one from the CPAD project, on the analysis side, the DUT requires a PDM clock frequency of 3.2 megahertz plus minus 200 ppm. Is this good or bad? You're shaking your head. Why do you think so? Well, actually, with frequencies, that's okay. With parts per million, that relates to frequencies just fine, but it can introduce some ambiguity to somebody who doesn't understand the relationship between frequency and parts per million. So it does depend on the intention of your specification, but you could just as well convert that to a plus minus hertz. This is actually a nice requirement because it gives us a specific frequency with a tolerance. We know the signal that we have to provide, and we know how precise we need to be on that signal. Yeah, so managing requirements is just as important as figuring these out in the first place. Once you have all these, what do you do with them? Well, you have to write them down. And this is where I was speaking to you about organization. You can break these up into different tiers of coverage. You can have requirements for individual fixtures or individual user interfaces based on the complexity of your project. That helps silo the complexity a little bit so that if you have a developer working on just one fixture or just one screen, he only has to care about those requirements and he's not hit with the rest of the noise of the larger application. So that can help reduce your individual developer or engineer's complexity by breaking these up in a reasonable way. What it does introduce is, of course, tiers, and you have to make sure then that your tiers of requirements still agree with each other. There is a difference between documenting your requirements and managing your requirements. Documenting your requirements is putting them down. So all the tools we see on the left, that's what you could use to document your requirements. That's not managing your requirements because there's a relationship between requirements and your project goals that is beyond just written text. It's very common to use unique identifiers so that you can always say, all right, this specific requirement, whether or not it's been redacted or changed, you can track it throughout the whole history of the project. And the tools on the right give you the capability to do that. They're purpose-built tools with the goal of recording requirements, tracking them through project lifecycle, allowing changes, collaboration, and then giving you a report at the end that says, here's all your requirements, this is how they've changed, here's how you can verify them. And verification, as we have talked about, is a critical stage here. Because requirements can and do change, it's not a bad thing that they change. But as you're changing them, you want to make sure that you're keeping your test up to date, or your verification plan up to date. And we have these 5 different tools in order to verify them. There's 5 different strategies. These are baseline. You may find other strategies as well, but these give you a baseline idea of how you might be able to verify different types of requirement with different strategies. Here's an example of a test report. So you can see there's written requirements, and based on the type of the requirement that we have here, you can maybe, there's only 2 different types here, but inspection versus demonstration. So for an inspection, we're talking about communication over an RS-232 port. Well, you can attach a serial logger there and inspect and see, yes, I'm passing RS-232 traffic, and that is working correctly. Compared to a requirement like the test software shall display an operator interface when the operator opens the test software, well, you launch the software, and you can see the test software open, and therefore you have demonstrated that that requirement was met. So in review, there's 4 major points that I want you guys to take home. Use requirements to familiarize yourself with a project and keep scope creep in check. This is the biggest enemy of timely and cost-effective projects, is not tracking what your goals are and then allowing them to change. You want to take advantage of existing standards and your own experience, your team's experience, to be able to write quality requirements based on your ability to verify them, based on your ability to define them on your customer's information, and set yourself up for requirements that you can prove. And you do that by writing your verification plan at the same time, making sure that you keep it up to date with your requirements as they evolve, so that you don't get 2 weeks out from delivery and find out the verification plan you have proves a completely different set of requirements. And finally, there's a lot of tools that you can use in order to make this process easier. You don't have to just open Notepad and pass that around the office. There are more complicated tools and there are less complicated tools. You need to decide based on the size of your team and the size of your project where that balancing point is. But these greatly streamline and augment your ability to define requirements well and then track them through the project so that you have a successful solution.